Okay, let's talk about similar shapes. Similar shapes are the same shape, different size. And we're going to talk about the ratio of the similar shapes. So you have to pay attention to the directions. Sometimes they'll say the ratio big to little, okay? The big shape to the small shape. In that case, whatever word they say first, you're going to take that number. So if I'm going to do big to little on this one, I'm going to write the words because that helps me making mistakes. And I'm going to take the base of the big one, 5, and I'm going to compare it to the base of the small one, 2. So this would be the ratio of side lengths for these two shapes, big to little. If it was little to big, it would be 2 over 5. So that's just the ratio of the side lengths. All right, now we also want to talk about the ratio of the perimeters. And when we talk about perimeter, it's one dimensional. Okay, it's just the measurement around. That the ratio of the perimeters is going to be exactly the same. And I want you to think about the labels it would use. So let's talk about side lengths. We would say this is 5 inches. For the perimeter, we would also use inches. So that way we don't change anything. Okay, so perimeter and side length, the ratios are going to be the same. If we talk about area, we have to think about the label. The label for area is inches squared. And so I'm going to take that ratio of the side lengths and I'm going to square it. Okay. In order to find that ratio, I would have to square the side length ratio. So I would get 25 because 5 squared is 25 and 2 squared is 4. So the area ratios would be 25 to 4. It's a two-dimensional figure. So you would have to square those. If you talk about volume, volume would be inches cubed. So if I have big to little side lengths, in order to find the ratios of the volume, I would have to cube this. So this would become 125 to 8. Now, let me show you an example of how you would use that. So let's say we have that for volume. And I want to find out, let's say I have the volume of the small one. Let's say the volume here is, I'm just going to use 10. So we're going to say 10 inches cubed. And I want to know the volume of the big one. In order to find a missing volume, I would do this. I would first find the ratio of volumes. So big to little, big to little is 125 over 8. That's the ratio of the volumes. Now, I know the volume of the small one is 10. So I'm going to put that with the little on the bottom. And I don't know the volume of the big one. So on top, I'm going to write an X. Now from there, I can use the butterfly method and multiply across. And when I do that, I get 8x, 8 times x equals 125 times 10, which would be 1,250. And then from there, I'm just going to solve. And I'm not actually going to do out the math. You can put that right into the calculator. And that would tell you the volume of the big shape. But in order to do that, in order to use proportions to do that, you have to cube the side lengths, okay, to get the ratio of volumes. If it was an area problem, you would square it, okay? And if it's perimeter, you would do nothing. And that's how you would solve those problems with similar shapes.